Okay, we are on section 4.6. So, okay. All right, section 4.6. First part is partner work. So you and your partner are going to use decimals. You're going to decide which one is periodic. So just graph it. What does periodic mean? Periodic means it has a pattern. It keeps repeating itself. Kind of like sine is periodic, tangent is periodic, cosecant is periodic. So there's like a pattern. You take that part and then just repeat. That's called periodic. So you're going to graph it and check A, B, C, D. Only one of them is periodic. Okay, just check on decimals. All right, let us check. How many people think A is periodic? Okay, nope. B is periodic? No. C is periodic. Okay. And then D is periodic. Peter thinks D is periodic. C. C is periodic. All right. How do you know if something is going to have a pattern? Well, here's what we do. If something is periodic, that means, after a certain amount of time, it will repeat itself. So then what we want to do is set f of x equal to f of x plus 2 pi. So what it means is after 2 pi, it should look exactly the same. The y value should come back to where it should be. So that means it's periodic. Okay, so we're trying to see if I put 2 pi later, will I get the same y value? All right, so let's look at one, for example. Verify that. So we already know that C is periodic. Now we need to check algebraically, why is sine x squared periodic? Okay, so to figure out that it's periodic algebraically, we're going to set f of x equals to f of x plus 2 pi. Okay, f of x is sine x squared. We're going to see if this is equal to sine x plus 2 pi. And then square it. So basically, wherever there is an x, I'm going to add 2 pi to it and say, does y come back to the same place if I just moved x down 2 pi? Well, let's look. Okay, so let's see. Sine x plus 2 pi. Sine x plus 2 pi. How often does sine repeat itself? 2 pi. Okay, so then if that x value here is pi over 2, 2 pi later, which point does it come back to? Same point, right? So then this 2 pi is just unnecessary. Kind of like, remember a few sections ago we kind of talked about that? That sine and cosine repeats itself every 2 pi. Tangent repeats itself every pi. So then this just becomes sine x squared equals sine x squared. So then they're the same, which means it is periodic. Yes, correct. It's unnecessary there. All right, let's have you try one. Sine cube x. Remember that sine cube x just means sine x cubed. It's the same. So the sine cube x is just a written way of writing this, but then in reality, you're doing sine x cubed. All right. So this is sine x cubed equals sine x plus 2 pi cubed. And it's kind of the same logic as before. This 2 pi just goes away. It really doesn't matter. It's a very boring proof, I guess. So sine x cubed is equal to sine x cubed. Okay. Next one is very interesting. I really like it. Find the domain, range, and period of the function f of x equals absolute value tangent x. When you see something like that, absolute value of tangent x, you're like, how does it look like? Well, just think through the whole tangent and how that looks like. So don't get really scared. Just think, how does tangent look like? Well, we know tangent is an increasing function. First of all, can you guys figure out the domain? Like, what does x not equal to? The asymptotes. So the question is, where are the asymptotes, right? The asymptotes depends on cosine, right? So the question is, what makes cosine 0? What x values make cosine 0? Because this one can't be 0. So what x values makes cosine 0?
Pi over 2.
Good, pi over 2. So x can't equal pi over 2. And the question is, so pi over 2 is here, right? 90 degrees. The question is, when is cosine 0 again? 3 pi over 2. Right? So then the question is, how often does that repeat?
Pi over 2. No.
Every pi.
Oh, yeah.
Right? So then plus pi k. And then k is an integer. Does that make sense? So when you look at tangent x, you're like, where is the domain? Well, I know they're asymptotes. Well, what makes the asymptotes? What makes denominator 0? What makes cosine 0 then? Cosine 0 is at 90 and 270. So then it's basically 90 degrees plus every 180. Okay, next part. Very interesting. Absolute value tangent x. Absolute value tangent x. Well, absolute value makes everything what? Positive. That means all the y values will have to be positive. That means there is nothing here. All this bottom part does not exist. So everything's going to flip up. Does that kind of make sense? So then all of these are going to flip up. Because no matter what x values you put in, all the y's will have to move up, meaning you just move all the y's up. So then what is the range on this absolute value tangent x? Yeah, greater than or equal to 0. What is the period on this? How often does this shape repeat? Pi. Because it's still the same period as tangent x. Still the same shape. It's just going to look like a V instead of a S, I guess. Okay, all right. So the people who are answering questions, I know you get it. The people who are not answering questions, just kept copying down. Try to kind of think through this whole thing with your partner. So let's have you guys try this next one. Domain, range, and period of f of x equals absolute value sine x. Absolute value sine x. So think through this whole thing. How does absolute value sine x look like without graphing on decimals? All right. The sine graph looked like this, but because there's an absolute value, so it's going to go up, so it looks like a lot of hills like that. So then domain is all real numbers. Range is going to be from 0 to 1. And the period was 2 pi, but now you flip it back up, so then you are repeating every pi. So whenever you get to something that you have never seen before, you can still analyze it based on your knowledge of what's going on. Okay, let's try another one. The graph of 0.5x plus sine x oscillates between two parallel lines. What are the equation of the two lines? All right, so basically sine x is going to stay between -1 and 1. So then the two equations are 0.5x plus 1 and 0.5x minus 1. Why is it 1? Sine. If you kind of think about it, sine kind of goes between 1 and -1. So basically, it's the sine graph just tilted. Okay, another partner work. you're going to graph these and then figure out which one appears to be sinusoid. All right, let's talk about what sinusoid means. Sinusoid means it looks like sine or it looks like cosine.
Yeah.
Which one of those looks like sine or cosine? Okay, so go ahead and graph it and check. Which ones are sinusoids? Remember, sinusoid looks just like sine, cosine, but maybe with some phase shift. But it's not just a pattern. It has to look like sine and cosine. Okay, raise your hand if you think A looks like a sinusoid. Okay, all right. Half of the class, good. That is correct. B. B looks like sinusoid? No. How about C? Okay, all right. Next thing you and your partner are going to do is you're going to look at all three equations and discuss what makes A and C look like sinusoid, but B does not. Just look at the equations. What makes A and C look like sinusoid, but B does not? All right, what do you guys think? What makes A and C sinusoid, but B does not? Okay, so a lot of you said, oh, B is 1. 1 is what makes it sinusoid. Not quite. You're close. What makes it a sinusoid is the periods are the same. You can see that 3 and 2 are not the same. That's why when you can't add them together, it won't look like a sinusoid. But these, they look the same, so then you can add them together. Okay, so let's summarize that. The sum and difference of two sinusoid must be a sinusoid if the two functions have the same period. So if you add them together and those sinusoid have the same period, it will look like a sinusoid. All right. Next one is just practice. Determine whether it is or not a sinusoid. So put yes or no. Yes, a sinusoid, not a sinusoid. What are you looking for?
B.
B. Yeah, see if B is the same. Just yes or no. All right. Okay, raise your hand if you think A is a sinusoid. Good. B is a sinusoid. No. C is a sinusoid. No. D is a sinusoid. All right, very good. Now, because they are sinusoids, so when two sinusoids have the same period, it's going to be another sinusoid. And because of that, we can write them as another equation. So, for example, this one. 2 sine x plus cosine x. Well, that has the same period, so we know it's going to look like a sine or look like a cosine. We're going to write them as a sine. Okay, so let's go ahead and try that. Put that in decimals. And we're going to try to write a sine equation based on what we see.